Assalamualaikum warahmatullahi wabarakatuh. In the last video, we've seen the properties of limit. In this video onwards, we will discuss on how to find limits. Take a look at the last page of your note. You can see this summary flowchart on how to find limit. And we will complete this flowchart bit by bit as the video progresses. To find limit, the first thing that you need to do is to start. Starting to do something is halfway done. Some people will be overwhelmed by the question that they don't even want to start doing it. So, this will be your reminder that you need to start somewhere to progress. Right, to start finding limits, all you need to do is to substitute. As I said in the previous video, most of the time, the value fx when x approaching a and the value fx when x is equal to a are usually the same. So that's why you need to substitute first to figure out which direction your case will be. If your answer is a constant or infinity, then that's it. This is your final answer. Let's move back to the 7th slide to see some examples. The slide with example number 3. For question A, we want to find the value of this function fx when x is approaching 3. All you need to do is to substitute the value x equals to 3 into this function here. So this is 3 to the power of 2 and the answer is 9. Since this is a constant, therefore, this is our final answer. See, not that hard, right? Let's proceed to question B. We want to find the value for this function fx when x is approaching 2. If you can recall from the properties of limits, we can separate this. We can, but we don't have to. I'll show you both ways so you can decide which is simpler. If I don't separate them, I just need to substitute x equals to 2, right? So I'm going to have 2 squared minus 3. So this is equal to 4 minus 3 and this is equal to 1. And since 1 is a constant, this is our final answer. But if you insist to separate them, just like in the properties, we can do that too. We can rewrite them as limit x approaching 2 for x squared minus with limit x approaching 2 for 3. And to find limit, we just need to substitute these two into this function here. So this will become 4. And from the first properties, this will become 3. And the answer is 1. See, the same answer. Properties is best used when we have unknown functions, just like in the exercise that you did in the previous video. If you know the function, it's easier to just substitute the value of x. But if you insist to use the properties, then go ahead. Okay, now your turn. I'll hold the video for 3 seconds and you try to do these 2 questions. You can pause the video if you need more time. So 3 seconds starts now. Alright, so let's see the answers. The answer for C is 6 and the answer for D is 9. Very good. Let's try again. Let's see if we can do this. Remember, don't be overwhelmed. We just need to substitute. For question A, substitute x equals to 3 here. If we substitute 3 here, we're going to get 9 minus 9 over 3 minus 3 and this is equal to 0 over 0. And this is not equal to 0. Also, there is no such thing as undefined in limits because the undefined value is for when x is equal to 3. In limits, we are trying to find the value when we are approaching 3. That means we need to be really close to 3 and not 3 itself. So every time we got this special 0 over 0 case, we need to do a little trick to get the answer. Now let's return to our flowchart in the last slide. This is case 1. The second case here is special when after we substitute the value of x, we got 0 over 0 just like in the example earlier. There are 2 things that we can do. We could either factorize or conjugate. How to know which? Well, if you can recall from the first semester, conjugate is when you want to rationalize sets. So when we have sets in our function, we are going to use rationalize. If not, we'll just use factorize. The point of these tricks is to cancel something from our function. Then we are going to substitute again. Now, let's see our previous question. We know that x minus 9 can be factorized to be x minus 3 and x plus 3. So let's write this back as limit x approaching 3, and then we know that x squared minus 9 can be factorized to be x minus 3 with x plus 3 over x minus 3. In the exam, do not show this calculation, so we need to delete this. Now, do you see what we can cancel here? Yes, we can cancel this x minus 3 with this x minus 3. So this here is just x plus 3. And then we are going to substitute again. So this becomes 3 plus 3. And the final answer is 6. And because 6 is a constant, this is our final answer. See? Not that difficult. One last example. Remember to substitute first to confirm your cases. So, substitute 4 here, you're going to get 4 minus 4 over 2 minus square root 4. So, this is equal to 0 over 0. Once you've confirmed your cases, make sure to erase this one back. Do not write this in your exam paper. So, now we have two options here. We could either factorize or conjugate. Since we have sets here, we can try conjugate. If you don't remember conjugate, I'll put the link down in description for you to go back and refresh your memory. As for you that already know, the conjugate for this one is 2 plus square root of x. So we are going to multiply both numerator and denominator with the conjugate like this. For this, we don't have to expand the numerator here. We just need to expand the denominator. You'll see why after this. So the denominator here will become 4 minus x. Now, we can easily see that we can cancel this 4 minus x. If you happen to expand the numerator too, it will be difficult to notice what to cancel. So here, we just have limit x approaching 4 for 2 plus square root x. So now we just need to substitute 4 into the function here. So we're going to have 2 plus square root of 4, and this is 2 plus 2, and the final answer is 4. Alright, so this is your exercise for this video. If you have any question or confusion, you could always ask in the comment section, or you could reach out to your lecturer. So that's it for now. Have a great day and take care.